In this video, we're going to go over the Delay tab and the Time Envelope feature in the Time tab. First, we'll look at the Delay tab. There are three options here for the delay method: Auto Delay, Set Values, and Use Memory List. Auto Delay is the default method, and it's recommended to use it. Auto Delay will use the peak of the impulse response to determine the delay in the entire chain. It will account for about plus or minus 1 second of delay. Basically what this means is that any delay in the system, be it from electronics, latency, or time of flight, will be calculated and accounted for. This allows the stimulus in the recorded time waveform to be correctly analyzed. With auto delay selected, you can see in the record delay everything here is grayed out, and in the memory list there is a value called record delay. The three values here represent the same delay, just in different units. There is time, distance, and samples. To illustrate exactly what this means, let's actually look at the stimulus and recorded time waveform. If we look at the calculated stimulus, it's a sweep that is calculated to start at exactly 0. But when we play this back, because of all the factors I mentioned before, the recorded time waveform won't start at 0. I zoomed in from 0 to 10 milliseconds on the stimulus, so let's do the same on the recorded time waveform. And here you can see it's just noise with no sine waves. Now we'll extend the graph from 0 to 50 milliseconds and change the color so it's a little easier to see. As you can see, there's about 36 milliseconds of noise before the recorded signal starts. In the acquisition step, we usually record for a little bit longer than the stimulus to account for this. That's why at the end you can see a little bit of silence as well. Now if we look at the record delay, it makes sense. Auto delay calculated, there's 36.2 milliseconds before the signal starts. We're recording at a 44.1 kHz sampling rate. At that sampling rate, 36.2 milliseconds translates to 1600 samples. Distance is calculated using the speed of sound compared to the record delay time. When using auto delay, there's also this option for a simple polarity check. When this checkbox is enabled, the Y value will be either positive or negative 1. If the polarity is positive, it will be +1, and if the polarity is negative, it will be -1. This function analyzes the peak of the impulse response and measures if it is negative or positive to determine the overall polarity. Instead of using auto delay, you can manually enter in these values. You can define the distance in inches or meters. Because these are all the same value just represented in different units, when you change one, all three of them will change. You can also use a memory list value. This can be useful if you calculate the delay in a sequence. That delay can be added to the memory list, you can select it here, choose the X, Y, or Z axis, and then what that relates to, be it samples, seconds, or distance. Again, unless this is a very specific application where you need to, we would recommend to leave auto delay on at all times. If we go to the Time tab, we can see in the Result Waveform section there is a Time Envelope checkbox. The rest of this tab will change depending on the algorithm in use, but the Time Envelope is always available. If we check this box, we can see a Time Envelope waveform show up in the memory list. There are only a couple controls here. We can change the scaling from linear to dB, and select a minimum and maximum frequency. This could be used for attack and release measurements, or to measure compression in a system.